Hello everyone, my name is Thomas Kim. This session continues from my previous video template metaprogramming 30 auto reference, auto R-value reference, DECL type auto. In this session we will learn what is perfect forwarding and what is type decay and what is universal reference or things like that. I created an empty file called type decay.cpp. Include IO stream, include talk play fun, type name.h, int main. We will first learn what is type decay. Type decay. Type decay means an array or a function turns to a pointer type when it is assigned to keyword auto or template parameter t. Type decay applies only to auto and template parameter t, and for array type and function type. int sum, int a, int b. Return a plus b. Int array 1, 2. Now let's display type of sum, type of array. std cout. The type of sum talk play fun get type category sum std enter std cout. The type of array talk play fun get type category array std enter. What's the problem? Okay, now let's build and test. dir type decay cl ehsc std c++17 type decay cpp fe mexe m. So the type of sum, this is function sum, type is int, it returns one int, and takes two int, two ints as parameter. So sums type is int, int, int. Array, the type of array, this array is int with two elements. Integer array with two elements. Now let's think what is type decay. Auto as sum auto ar array std cout. The type of as talk play fun get type category as std and there std cout. The type of ar talk play fun get type category ar std and there. Okay, now let's run it. Let's see. Sum is function int, int. Array's type is int with two elements. In this case, sum's type, this is pointer, function pointer. And in this case, array ar's type becomes integer pointer. Okay. Let's go up. I said the type decay applies only to auto and template parameter t and for array type and function type. We tested about keyword auto. Now let's test about template parameter t. Okay, I create a template function, template type name t void print type tb like this. I will put some message here, constant character string message std cout msg talk play fun get type category v std and there I create another function print type t as reference. I modify it into reference like this. Now scroll down. Print type t sums type passed as template, I say as parameter t sum print type t arrays type passed as parameter t array. I will copy the same function template print type t as reference, sums type passed as parameter t reference. Print t as reference, arrays type passed as parameter reference. M. Now let's see. I will scroll up here. Sums type passed as parameter t. It is function pointer. This is pointer, function pointer. Arrays type passed as parameter t. It is also integer pointer. Sums type passed as parameter t reference. It is function reference. This is function reference. Arrays type passed as parameter t reference. It is integer array with 2 elements. An integer array with 2 elements. It is reference. So type decay did not happen in this case. Print type t as reference. We passed as parameter t reference. In this case, type decay did not occur. Only in this case, only when sums type passed as parameter t, type decay occurs into function pointer, array as integer pointer. This is what type decay means. In this template function, t is called template parameter. T is called template parameter. In this case, v is called function call parameter. Okay, so t is template parameter. Here v is called function call parameter or call parameter. We displayed the type of v, function call parameter. We also need to know the type of t. std cout, the type of t. In this case, talk, play, fun, get type name. Then we pass type t, std, and there. I copied this and I paste it here. Now I call this function again. I compile this function again. M. Now let's examine once again. The sums passed type as parameter t. This function pointer to function int, int, int. The type of t, the type of t here, this line of code, int pointer, int, int. So this type and v, the call parameter type are the same in this case. But in this case, sums type passed as parameter t reference, this function pointer, the type of v is reference, function reference. The type of t, in this case, the type of t, function type. This is function type, this is function type, this is v type. In this case, array passed as parameter t reference. This is array reference. This is v type. In this case, T is the type of array. In template metaprogramming, we have to figure out function call parameter V's type as well as T's type. In this function, type of T and type of V are identical. Type of T and type of V in this function call are identical. This one identical. This is integer pointer, identical. In this case, different. V is reference. Some type is this is reference. This is not reference. T is not reference. V is reference. Here, this is reference. The type of T is not reference. We have to know both template parameter type T and the function call parameter type. We have to know both types for successful template metaprogramming. I will change this function name void test type decay like this. I change it int main test type decay, and I disable it, and I scroll up. Now I declare an int a, for example 5, auto b a, auto c a, auto d a, decl type, auto e a. I create here another one int l a. Now here decl type, auto f l. Please note that in this case, in case of auto, keyword auto creates an instance using copy constructor. So this type is int and is a copy of a. Okay, here auto, this is L value reference, is an L value reference. In this case, sys type is int reference. Auto L value reference does not create an instance. It is simply L value reference. In this case, auto, this is called generic reference, does not create an instance, it becomes either L value reference or R value reference. In this case, please note that A is a local value, local integer. Decay type auto creates an instance if its argument, in this case A, is not a reference. Since the type of A is not a reference, I say not a reference or pointer. A is not a reference nor a pointer. Its type is int and is a copy of A. In this case, here L is reference if the argument in this case L is a reference, L value reference or R value reference, or a pointer, then Decay type auto does not create an instance. It becomes simply a reference or pointer. I will create a pointer here, int ptr. In this case ptr is pointer, and Decay type auto ptr. Since ptr is a pointer, p is just a pointer, exactly the same to ptr. This concept is actually important. Okay, understanding this concept is actually important. I will copy this whole part up to here, and I will create a function void compare auto decay type auto. I pasted the code here. Okay, how can it test its type? Well, we learned this. We learned how to use get type type category, we will use this function, this command here. The type of B okay, I will copy multiple times. I copied, pasted here. I will copy once again, copied, and I paste it here, and I paste it here once again, and here once again. Then I fix the type of B, the type of C. I fixed like this. The type of D, the type of this case E, I will copy this code, cut, paste here, cut, I will paste it here, like this. Then the type of E, and here the type of F, and the type of P. I will copy this part once again. The type of P, Let's examine once again. Type of B, type of C, type of D, type of E, type of F, type of P. See, in this case, when argument, this assignment A, this value, it is neither, this is not pointer or reference, the value is created. Okay, B is an instance, a copy of A. Okay, in this case, it is just a L value reference. In this case, since A is L value, it becomes L value reference. In this case, D becomes L value reference. We can check it. In this case, A is this value. Since this is not a pointer or not a reference, E is simply a copy. Okay, and in this case, L is reference, so it is also a reference. F and L are exactly the same reference. Okay, and in this case, PTR is pointer, so P becomes exactly a pointer. Now let's call this function. Copied and paste dir cl ehsc type decay cpp. I will put std C++17 FEMEXE. Okay, so let's run M. Now goes up. Let's compare. So B is int means it is an instance, a copy of A. In this case, C is integer reference, L value reference. In this case, D is also integer reference, L value reference, because A is L value. And in this case, A is L value. This is just not a reference. A is not a reference. So E is just int. It is an instance. Is copied. And in this case, F. In this case, because L is reference here, you can see reference. So F becomes reference. Since in this case, PTR is pointer, so P becomes pointer. Understanding this plays very important role in template metaprogramming. So please try to understand it by yourself and experiment it enough. I will put this code here and take some time to understand. Then I will talk about perfect forwarding. I will give you 20 seconds to think. Then we will move on to perfect forwarding. Let me summarize what we have learned so far in this session. For any object, auto reference A object never creates an instance. It is simply L value reference. For any value auto B object never creates an instance. It is either L value reference or R value reference. Auto C object, if object is not a pointer, it always creates an instance. Even if object is a reference, it still creates. But if the object is a function type or an array, then C is a function pointer or a pointer to that array. DECL type auto object, if D is not a reference nor a pointer, then D is a copy of the object. I haven't talked this, but if The object is a function type or an array type. It causes syntax error. Now let's talk about perfect forwarding or forwarding reference or universal reference. Universal reference, forwarding reference, or perfect forwarding all means the same thing. The primary purpose of universal reference or forwarding reference is to recycle R value. If we cannot recycle R values, universal reference or forwarding reference loses its raison d'etre. So to recycle R values, we need not only universal references, we also need to have move constructor and move assignment operator. Universal reference, move constructor, move assignment operator. R values should play a good teamwork. Otherwise, if one party fails its duty, then we cannot gain any performance gain. If we cannot gain any performance through universal reference, or is called perfect forwarding, we just waste our efforts and the time that we put to achieve this goal. Universal reference, forwarding reference, or perfect forwarding all means the same thing. The primary purpose of universal reference or forwarding reference is to recycle R values, we cannot recycle. If we cannot recycle R values, universal reference or forwarding reference loses its raison d'etre. So to recycle R values, we need not only universal reference, we also need to have move constructor and move assignment operator. Universal reference, move constructor, move assignment operator R values should play a good teamwork. Otherwise, if one party fails its duty, then we cannot earn any performance gain. If we cannot gain any performance through universal reference, or is called perfect forwarding, we just waste our efforts and time that we put in to achieve this goal. Universal reference means it can reference to any type. Forwarding reference means its purpose is to forward R value. Perfect forwarding means we should not lose R value needs of the expression when forwarding. The R value to another function. Now let's examine the syntax. For template function, type name T, forwarding reference T, F, where T is template parameter, F is function call parameter. This T, the template parameter T in the function call parameter list should be of the form T reference. So in the above function call parameter list, F is forwarding reference, Y is called universal reference, Y is called perfect forwarding reference. Now let's see some more examples. Template, type name T1, type name T2, type name T3, type name T4, void tell the universal reference T1 T A1 constant T2 A2 T3 A3 T4 A4. This is function call parameter list. Function call parameter list includes all these things, where A1 is universal reference, A2 is not universal reference because constant is decorated. A3 is not universal reference because it does not have R value reference. A4 is not universal reference because T4 is L value reference. Universal reference is reference. It can be any kind of reference. Any kinds of references. It can be L value reference. It can be R value reference. It is always some sort of reference. I will fix this. There is another kind of universal reference. Template, type name, T1, type name, T2, type name, types, void, more complex, universal references, T1, constant T1, A1, I would say T1 RR, A, constant T2 R, A2, types, ARGS. In this function, in this case of function, this function call parameter T1, no, A1 is a universal reference. A2 is not universal reference. ARGS are universal reference parameter pack. This is called parameter pack. This means types means 0 or more or arbitrary types. Types means 0 or more of universal references of arbitrary types. Now let's try some code. Here, template type name T void my first universal reference T V. Here std cout type of T talk play fun get type name type name T std and there std cout the type of B talk play fun get type category B std and there std cout the value of B std and there std and there. Now I make a function test universal reference inta 5 int r reference l value reference a int r value reference 5. Now we are calling this function. I will put a message here constant character msg std cout msg std and there. My first universal reference A INTA 5 as parameter as argument, then I copied int r value L A as argument L. I copy once again RR 5 as argument R. Lastly, here int literal value 10 as argument 10. I will copy this A is moved. Here std move A. I copy once again. No, I will copy this part. R is forwarded. std forward int rr now we are calling this function. I copied, pasted here. I will disable this part. Sorry, I will rearrange a little bit. Now let's build. CL EHSC type Decay CPP std C++17 FE MEXE. Wow, it compiled. Now let's see how these values are processed. M. So here CLS M value A, this A is forwarded, this A type of T this T is int L value reference. Type of V, it means A's type is L value reference. Value of A, this is A, we passed 5. Now here we call this syntax L reference. Type of T L value reference, type of V L value reference, value 5. So the result is the same. This call and this call, the results are the same. In this case, we pass R5, this is R value reference. We passed as a parameter, as argument R here. T, the type of T becomes L value reference. The value of V becomes L value reference, and the value of V becomes 5 because A is reference. So this case, the first call, second call, third call, all are the same. Now let's see this one, this call here, int literal value 10 as argument. Type of T, this T is int. Type of V, when we pass the 10, it becomes V becomes R value reference. V type becomes R value reference because 10 is passed as R value. the value v is 10. Now let's see this one. This one we moved. In this case, int a5, a is moved, t is int, and v becomes v's type becomes int r value reference, and the value of a is 5. Please compare this one, and this one. Okay. In this case, this is L value reference, L value reference. In this case, it becomes int, this type becomes int, and the parameter this type becomes R value reference. So this is and this is different, and these are the same. So this function call and this function call are the same. And in this case, we now forward R value like this with this syntax. Then the result are this one, the same, this one, the same. So I will give more detailed explanation in next video, because to completely understand forwarding reference or universal reference, we need to create a class, and we have to create copy constructor and copy assignment. Without such things, explaining forward reference or perfect forwarding is meaningless. Please subscribe to my YouTube channel. Please don't fail to watch my next video. Thank you for watching.